Hello dear student. In previous lecture we have seen BGM method and some problems on a BGM method. So today we will see duality and the formulation of the dual problem. First we will see what do you mean by duality. What is the definition of the duality? Duality means every LPP maximum or minimum, there exists another LPP which is based upon the same data having the same solution. The original problem is called as the primal problem, while the associated one is called as the its dual problem. That means a problem having the same data. First problem will be the primal problem, and another problem is called as the dual of that problem. Okay, so this is the simple definition of the duality. Okay, now we will see the general primal dual pair. What do you mean by primal problem and what is the dual problem? Okay, first we will see the standard primal problem form. If maximum z equal to c1 x1 plus c2 x2 plus and so on cn xn, subject to the constant ai1 x1 plus ai2 x2 plus and so on plus ain1 xn equal to b I equal to 1 to m, xj greater than equal to 0, j equal to 1 to n, where x1 x2 xn are the primal problem. Okay, so this is the standard form of the primal problem. Now we will see the dual of this problem. If the problem is maximum, then its dual is minimum z star. If the problem is maximum, then its dual is minimum z star. And dual of this is b1 w1 plus b2 w2 plus and so on bm wm, subject to the constant a j w1 plus a2 j w2 plus and so on a m j w m greater than equal to cj, j equal to 1 to m, where wi greater than equal to 0, I equal to 1 to m. So where w1 w2 wm are called as the dual variables and it is unrestricted. So this is the dual problem of this primal problem. Okay, so this is the conversations of the primal to dual problem. Now we will see the matrix notation of the primal to dual. Okay, so in matrix notation can be written as find x transpose belong to r raised to power n, subject to as maximum z equal to cx, which is our objective function, subject to the constant ax equal to b, x greater than equal to 0, where A is m cross n, a real matrix. Okay, then the dual of this problem can be written as minimum z star equal to b transpose w, subject to the constant A transpose w greater than equal to c transpose, where A transpose is the transpose of the m cross n of a real matrix A and w is unrestricted in sign, or we can say that w is a dual variable of the primal problem. So this is the matrix notation of the primal to dual. Okay, now we will see how to convert minimum problem to maximum problem, or we can say that if the problem is in the form of minimum, then what is the dual of that problem? Okay, let us see standard primal form. If the problem is minimum z equal to c1 x1 plus and so on cn xn, then subject to constant is given as ai1 x1 plus ai2 x2 plus and so on ain xn equal to bi, where I varying from 1 to m, xj greater than equal to 0, j equal to 1 to n. So here x1 x2 xn are called as the primal variable. Okay, so here given the problem is in the form of minimization, then what is the dual of this problem? The dual of this problem is given as minimum of z, so here we will convert maximum z star, b1 w1 plus b2 w2 plus and so on bm wm. So this is the dual objective function of the this objective function, subject to constant a I a1 j w1 plus a2 j w2 plus and so on am j wm less than equal to cj, j equal to 1 to n. wi greater than equal to 0, I have from 1 to m. So where w1, w2, wm are the dual variable and it is unrestricted in sign. Okay, so this is the conversations of the minimum primal problem to the maximum dual problem. Okay, then the matrix notation, in matrix notation we can write in this way, so find x transpose belong to r raised to power n so as to minimum z equal to cx, ax equal to b, x greater than equal to 0. So here A is a m cross n real matrix. Then the dual of this problem can be written in a matrix form as find W2. Here we have to find out the W variables, dual variables. WT belongs to R raised to power M. So as to maximum Z star equal to B transpose W, subject to constraints A transpose W less than equal to C transpose. So where A transpose is the transpose of M cross N real matrix A. Okay. So if the problem is dual problem is in the form maximization, so this sign always less than equal to, should be less than equal to. Okay. Okay. Now we will see algorithm, how to formulate dual problem, primal to dual problem. So let us see the algorithm. The dual problem of the given LPP is obtained by the following step. How to obtain the dual problem from a given primal problem. So we will see the some steps. What is first step? A LPP is said to be is in standard primal form. When we say that the given LPP is in primal standard form, first all the constant involves the sign less than equal to. If it is a problem of maximization, if the problem is maximization type, then all the constants should be less than equal to sign. If the problem is maximization type, then all the constants should be less than equal to. Then we can say that the given problem is in the primal standard form. Okay. Second case is all the constant involves the sign less than equal to. All the constant involves the sign less than equal to. If it is a problem of minimization, means if the problem is minimization, then it contains greater than equal to sign. It should be contain greater than equal to sign. Then we can say that the given primal problem is in a primal standard form. Okay, so this is the step number 1. Now see the second step. If the system consists of a mixture of equations, inequality is a non-negative variable or unrestricted variable, then suppose if the given problems contains mixed inequality or equations, then what we have to do? Okay, case number 1, if a constant has a sign greater than equal to, then multiply both side by -1 and make the sign less than equal to. Okay, suppose the given problem is maximization and there is a greater than equal to sign. Okay, then we have to multiply that constant by -1. Then that constant can be converted in the form of less than equal to. Okay, second, if the constant has a sign equal to, then we take two constants involving the sign less than equal to and greater than equal to. Suppose that if the problem is in the form of uh, maximization or minimization and there is a sign equal to sign. Okay, so this equal to sign can be convert into the two constants less than equal to sign and greater than equal to sign. Okay. For example, x1 plus x2 equal to 2. So this constraint can be written in the following form: x1 plus x2 less than equal to 2, and second constraint will be x1 plus x2 greater than equal to 2. Okay, so this is the conversations of the equality sign. Now, step number 3. Identify the dual variables to the used in the dual problem. The number of dual variables equals to the number of constant equation in the primal problem. Then we have to find out find out the dual problem. Then we have to find out the dual of the given primal problem. So for that we have to identify how many dual variable we required, how many dual variable we require for the dual problem. Okay. So it is given as the number of dual variables equals to the number of constant. If there are 4 constant or 3 constant, suppose there are 3 constant in primal problem, then we require only 3 dual variables. Okay. Step number 4. Write down the objective function of the dual. Then in step number 4 we have to take the dual of the given primal problem using the right hand side constant of the primal constant. Okay. Then if the primal problem is of maximization type, then the dual will be minimization problem and vice versa. Okay. If the problem is maximization type, then the dual of that problem is in minimization, and if the problem is minimization, then the dual of that problem is maximization. Okay. If the objective function is maximization, then dual of that objective function will becomes minimization, and if the objective function is in the form of minimization, then the dual objective function will be becomes maximization, and vice versa, we can say the vice versa. Okay. Then step number 5, making use of dual variables identified in step number 3, write the constant for the dual problem. Okay. So then after that we have to identify the dual variables. Okay. If the primal is a maximization problem, then the dual constant must be all of greater than equal to type. Okay. If the problem is maximization, if the primal problem is in the form of maximization type, okay, then the dual constant should be greater than equal to type. Okay, understood? If the primal problem is maximization type, okay, then the dual constant must be all of greater than equal to type. Second, if the primal is a minimization problem, then the dual constant must be all of the less than equal to type. Okay, so then the column coefficients of the primal constant becomes the row coefficients of the dual constant. Okay, that means the column coefficients of the primal constant, okay, becomes the row coefficients of the dual constant. Then see, the coefficients of the primal objective function becomes the RHS constant of the dual constant. And last is the dual variables are defined to be unrestricted in sign. So these are the 5 cases arises when we are write down the dual variables or dual problems. Okay. Then step number 6, using step number 4 and 5, write down the dual of the given LPP, and every unrestricted variable is replaced by difference of 2 variables. Then finally we have to write down the dual of the given primal problem. If there is a common difference between 2 variables, then we replace by that variable by the unrestricted variable, that means dual variable. Okay. So this is the uh, algorithm of the dual problem. Now we will see the one problems on this. Obtain the dual of the given problem. So given problem is maximum z equal to 5x1 plus 3x2 subject to constant 3x1 plus 5x2 less than equal to 15, 5x1 plus 2x2 less than equal to 10, x1 x2 greater than equal to 0. Okay. Now we have to obtain the dual of this problem. Okay. What is the solution? Write down the given. So given LPP can be written in standard primal form. First we have to find out the primal form. Primal form is it primal form? Yes. Given problem is maximum type, and the sign is less than equal to, and hence we can say that the given problem is in the primal standard form. Okay. Okay, so here problem is maximization type, and the sign and the both sign less than equal to, and hence we can say that the given LPP is in a primal standard form. where x1, x2 are called as the primal variables. Okay. Now we have to identify the dual variables. How many constant here? There are two constants. So therefore we can take W1, W2 are the dual variables. Number of constant equal to the number of dual variable according to the algorithm. So therefore we want here only two dual variables W1, W2. So let W1, W2 be the required dual variables corresponding to the primal constant. Then the dual of the given LPP can be written as. Okay, now we will take the dual of this problem. So here is the problem is maximum, then the dual of this is that is minimum Z star. Okay, so so this column, this column will become row, that is 15 W1 plus 10 W2. That means this will becomes objective function. Then subject to constraint A transpose means 3W1 plus 5W2. So this column will becomes row. Okay, that means 3W1 plus 5W2 and greater than equal to C1. C1 means this C1, that is 5. Okay, so this is the first constraint. Then second, 5W1 plus 2W2 greater than equal to C2. C2 means this is 3, that is 3. W1, W2 greater than equal to 0. So this is the primal problem of a this is the dual problem of a given primal problem. Okay, so this is a simple example on a dual problem. Okay, this is very easy problem. Okay, so now we will see the second problem. Minimum z equal to 4x1 plus 6x2 plus 18x3 subject to constant x1 plus 3x2 greater than equal to 3, x1 plus 2x2 greater than equal to 5, x1, x2, x3 greater than equal to 0. Okay, so here problem is in form of minimization and all the sign is greater than equal to. So therefore we can say that the given problem is in a primal standard form, because here is problem and sign is greater than equal to. Okay, so given LPP can be written in standard primal form as, so this is already is in primal standard form because all the sign in a constant greater than and equal to. So x1, x2, x3 are called as a primal variables. Now we have to identify the dual variable. How many constants? There are two constants, 1 and this is 2, 1 and 2. So W1, W2 are the required dual variables corresponding to the primal constant. Then the dual of this problem can be written as, so this is minimum, then the dual of this problem is maximum Z star. So 3 and 5 will becomes objective function constant. So this column will becomes row, that is 3 with W1 plus 5 W2 subject to constant. So this column will becomes row, this column will becomes second constant. And okay, first, that is W1 plus W2 plus W3, because here is a third variable x3 plus 0 W3. Okay, maximum, that means less than equal to sign, less than equal to, and C1 means 4, less than equal to C1 means 4, second constant. So here 3W1 plus x2 absent variable, so we can write 0 W2 plus x2 again, sorry, 3W1 plus 0 W2 because x2 is absent, then plus 0 W3 less than equal to C2, that is 6. Okay, then 0 W1 means here x3 absent, 0 W1 plus 0 W2 0 W2, okay, plus 2W3, 2W3 less than equal to 18. So where W1, W2, W3 greater than equal to 0. Okay. So this is the dual problem of a given primal problem. So these are the two examples on a dual problems.